Okay, terminal voltage part 2. Our Giancoli textbook likes this equation. Okay, the voltage across the terminal is equal to the electromotive force minus the voltage that you would see basically lost from the resistance, the voltage that drops. So I'm going to start with that equation. And I'm also going to use this equation. Okay, remember the circuit we had was basically this. You should get some practice drawing these. And this basically here is the inside of your battery, and there's a 65 ohm resistant there, we'll call that R, and there's a little 0.5 ohm resistance there, and the EMF is 12 full volts. Okay, well, the voltage across terminals A and B would be IR, and that's equal to electromotive force minus I times little r. And I could, if I want to solve for I, the current, I could add I little r to the other side. I can factor out an I. Then I could divide. Okay? So the current would be the electromotive force of 12 volts divided by the sum of the two, which is 65.5 ohms, which gives me 0.1832 amps. Okay, so that, remember, there'd be the same current in both places because they're basically in series. Okay, so if I want to find now VAB, so I'm going to switch colors here. VAB, again, equals E minus I little r. So VAB would be 12 volts minus my current times my little r, which is 0.5 ohms. And I work that in the calculator and get 11.9 volts. So that's what's seen across the terminals if we were to measure it. Okay, so 11.9 volts. So now let's say I wanted to find the power in each of those resistors. So let's find the power in the big resistor, let's find the power in the little resistor. Okay, so a little bit of thinking. So I know power, that green's not working, let's try this. Power equals IV, and also V equals IR. So I can say power equals I times IR. So power equals I squared R, which is another form of the power equation. So I could do 0.1832 amps squared times my little resistance for big R. And I'm going to get 2.18 watts. I'm going to do the same thing for little r. And I'm going to get 0.02 watts. Okay? And again, those are just different ways, a different way of looking at this equation and this system. You will find that this equation here is useful in a lot of problems in the Giancoli textbook.